I'm going to talk to you a bit about cybersecurity, safety, and resilience, and how we at MDU are working on these subjects and projects, and how and what we have to offer you. Okay, we are all looking for trustworthiness, which includes reliability, safety, security, resilience, among others. And the definition of cyber resilience from this NIST report in December 2021 is that a computer system's ability to continuously deliver the intended outcome despite adverse cyber events. And the main thing is that we need to architect, design, and develop and then sustain this trustworthiness of the system with the capability to anticipate, withstand, recover, and adapt when there is an attack. So cybersecurity's focus is more on detect, protect, and defend, and cyber resiliency is about also adding to that, also reacting, adapting, and recovering. So we need resiliency against complicated situations. So it's not only to keep it safe and secure, it's also being able to actually handle the complicated situation when we have an advanced persistent threat and there's an adversary that has significant levels of expertise and also resources. It's not simple. There can be multiple and coordinated attacks, both at levels of cyber and physical layers. So we need security measures to be built in. So as you said, we need security by design. So as you see, it needs to be a foundational part of the architecture and design. So cyber resilience cannot be tested in. We have to start with security in mind. Like other qualities in software, we need requirement engineering, design models, architecture, and analysis techniques to make it possible. And this is not against DevOps. So when I talk about these things, the first thing Edward, I remember, he told me, he said, you're talking about waterfall. I'm not talking about waterfall. All of these can be also in agile processes. So the challenges that we have nowadays is that, as Jan was saying, we have open, connected, and heterogeneous systems. We had cloud to edge to core. We also have dynamicity. We have a changing environment. And we have DevOps. We have software updates and changes. So these are all the things that makes the problem more challenging and complicated. And we have time-sensitive systems. So deadlines are important, and we have time constraints. So you can see that in this ABB robotics example. This is an example of an open, connected, heterogeneous, dynamic, and time-sensitive system. There is no fence around the robot anymore. If there's a human being coming into this yellow area, the robot slowed down. I hope you noticed that's how it slowed down. And if it comes into the red area, the robot stands still. So this is what we now have to handle, the collaborative robot that works without a fence and human beings can be around. This is another example where we have a vehicle to everything communication. This is from Volvo Cars side. So cars are smart. They can sense that there is an obstacle, a pedestrian, another car. They need to stop, slow down, and stop. Or even further than that, we have cars connected to the cloud. If there is an accident further on, they notice that by the other car and they can stop or change route or anything like that. So again, we have these cyber physical systems and we have all these levels of cloud edge and the machine, the car, the thing itself. So the aspects that we have in the system now that they are open and connected. So what happens is that there's increased risk and threats to safety and security. So we need to go for cyber resiliency. We have heterogeneous systems, so we need to have software and components that are interoperable. So we need a modular design and clear interfaces. Systems are dynamic, so we need adaptability. We need runtime monitoring and planning. runtime assurance and AI, and they're also time sensitive. So we need to be time predictable, we need time models and time analysis. So in us at MDU and in our research groups, we are providing many things. Among that, we are working on self-adaptive systems, MAPE architectures, runtime monitors, and optimal placements. And one of the challenges here, again, as Jan Bosch also said that in other terminology, but we need to have performance and time sensitivity, and also we need to be able to change the design in short cycles. And at the same time, we need trustworthiness. And Edward will talk about something relevant to this topic later. We need cybersecurity in mind at design time. So adding security as an afterthought is complicated or maybe even impossible. Yeah, I wrote in small fonts where I got some of the ideas in the slide. Okay, adaptive architecture. So we need to be adaptive or the user will not be happy. Even more than that, we need to get the specification and look at the specification and then based on the specification, you have to be so adaptive that you just make what the requirements are telling. I got so excited by those videos. I don't see you guys get so excited. So we have this software center project number 29 on modeling and analyzing cyber physical systems, and it's an umbrella on most of the things that we do, and among that is timing analysis, focus on timing analysis, and also cybersecurity. So I will tell you a bit about that. We have Volvo Cars. Actually, Jan Lantz was the guy who supported me from the beginning to put up this project, and then we have Volvo Construction Equipment, who were there from the beginning, and Dive from Denmark, who joined us. So in general, we are working on this framework. We call it Crystal. We have this MAPE architecture for self-adaptive systems. It's like the autonomous cycle. And we added a tiny digital twin as a model at runtime. This is a regular behavior of the system. We put it there, and the monitor can check if the behavior of the system is along the way that the regular behavior is supposed to be using this tiny digital twin. And then if there is something that is violating, and if we observe some anomaly, which is against the safety or security, then we can react and also at some point adapt, I hope, in the extension of the project. So we identify the threats using Stride. That's what at Volvo CE we picked up at Volvo CE, the work we did at Volvo CE. Then we develop a runtime monitor to check the system behavior at runtime using this tiny digital twin that also it can be changed when the software is changed. And we have to extend it to provide mitigation and recovering plans. We also are learning it's a new project to learn this kind of digital twin as an automaton using genetic programming or other AI approaches. We have PhD students and experts talking about this later on. So the highlights of our project is that we are combining formal methods and model-based methods. And again, we stay agile, and we are using the ideas in MAPE architecture, model-based testing, and runtime verification. We pick the ideas from different domains, and the ones that we thought it's the best for what we're doing. So we don't have, for example, runtime verification based on a logical property. We have it based on the regular behavior. And the tiny digital twin is based on an executable code, which is much more precise than a specification-based detection based on rules. And we have possibility of adaptive responses because we know what we are expecting to happen later. We also have design time and runtime cycles together. So we use our model, the actor-based model, Rebecca, with formal verification support at design time. And then we build this tiny digital twin based on a branching by simulation of the state space. And we are respecting time constraints. We use an executable language, lingua franca, which is kind of dual to Rebecca for us, to solve synchronization of logical time in the model and the physical time in the system. And you will hear about lingua franca later when Sarush gives his talk. So Hans was asking me, what do you have to offer? You're not telling very well what you have to offer. I hope you got from my talk what I said, what we have all these approaches and methods. We think they're cool. How you want to apply them, how you can apply them, I need to talk to you to be able to say more. But we have experiments and examples and case studies, real world case studies to try that ourselves. And also our collaboration with the companies I told you. With ABB also, we are moving forward. So now I switch to the projects at MDU. We have Serendipity, which is a large project on cybersecurity, secure and dependable platforms for autonomy. MIC is the PI, and there are 4 work packages led by Mick, Elizabeth, Christina, and myself. And actually what we did, we build upon the background that we have on dependable systems. Dependability is surviving unintentional faults, and security is surviving intentional faults. So we built upon that hypothesis, security and safety can be addressed in a uniform manner based on these features. We are working on that, and Barbara is going to talk about that a bit later. So the outcomes of Serendipity so far is that we have ontology for safety and security. I hope we can have another workshop like this, and then Luciana will tell you about this. Joint requirements management for safety and security. We have automatic vulnerability detection. This is Crystal actually, identify for safety hazards and security vulnerabilities. Sara and Feridun are working on that. Friendly jamming in wireless networks, adding a known jamming signal to prevent eavesdropping that Elizabeth is working. Elizabeth is working on security now for many years. So we have SACSys, safe and secure adaptive collaborative systems here. This is a KKS synergy project. I'm the PI. And we have Edward and David Garland as our external advisors, and we have Alessandro Antonio, and actually Ida, who is no more with us, but she is now an associate professor and working now as at previous Bombardier. What is the name now? Alstom. So we are working on actor-based platform for adaptive collaborative systems, continuous and adaptive safety and security assurance. Again, Barbara will talk about this. Real-time cloud and fog computing, which is Alessandro. The research outcomes is, this is what, again, Barbara will tell you about, contribution to safety and security assurance together, putting together. Microsoft threat modeling method Stride, we use it to detect attacks. Automated mappings between views of the system at different levels, like UML, Rebecca, lingua franca. This is Antonio is leading this, and runtime monitoring and identification of malicious nodes in a distributed system with a divide and conquer approach. The idea is like a binary search. I like the idea. This is the work of Alessandro, who is working on cloud and runtime analysis. And adaptive machine learning models for detecting attacks. We started, and Maksud has started to work on that. We have a VeriDevOps, which is automated protection and prevention to meet security requirements in DevOps environment by Edward. It's an Edge 2020 project working on faster feedback loop for verifying the security requirements in large-scale cyber physical systems. I tell you these things, then you know people and you can contact us about that. Insect, Sashi and Hans are working on that. PI is Sashi. They're working on AI and IoT. So basically and mainly working on access control for smart manufacturing and anomaly detection by federated learning for industrial network. And we have our AI group, like Shahina is working on increased trustworthiness of AI systems using explainable AI. And we have another European project led by Mubin, who is working on transparency for AI security and again, explainable AI for air traffic management systems. Apart from the research projects, we have our industrial PhD students, for example, Are, and we have Bjorn working on automatic generation of access control policy and enforcement architecture, ensuring that policies followed at runtime. And now I don't have time much more. Some advertisement, we have Reliant PhD School, and we are looking for partners. This will be a good opportunity for industry to have PhD students being here at MDU and also at the company. And more than that, we have MDU educational offerings that Hans is basically behind that. And you can look at that, actually look at the slides online. So I will finish now to be actually in time. These are terminology. I'm obsessed and confused with terminology all the time, so I put that there. And how all these things are connected to good old dependability. So the slides will be online.